Welcome to your geometry week of November 8th. We are in week 13. I do want you guys to, before we get started, complete this warm-up question that I have that is a parallelogram where the sides are labeled accordingly. We've got some variables involved in the lengths of our sides. And I want you to focus on solving for y. And I want you to complete this problem in your math notebook. In a moment, you're going to press pause so that you can complete this in your math notebook. But before you get there, I want you to think back of what you learned about parallelograms last week that will help you solve this problem. So what did you learn about the properties of parallelograms last week that will help you solve for y? So go ahead and press pause now and complete this in your math notebook, and then when you're ready to check your work with mine, go ahead and click play. All right, so what do we know about parallelograms that's going to help us solve this problem? So we learned last week that the opposite sides are parallel of parallelograms. We also learned that the opposite sides of parallelograms are going to be congruent. So if we know the opposite sides are congruent, then we know that this side here has to be congruent with this side here. So I'm going to put a tick in those two sides because we know one tick on each of those sides lets us know that those two sides are congruent. So if we know those two sides are congruent, we can then say that this side that is represented by 4y minus 3 is congruent to the side opposite. It's going to be set equal to the side that's represented by the length 2y plus 7. So we just set those two equations equal to each other because we know they are equal because the opposite sides of parallelograms are congruent or equal. And now we're just going to solve for y. We're going to use our algebra skills and solve for y. So I'm going to subtract 2y from both sides. I'm going to work on getting all my y terms on one side of the equation and all my constant terms on the other side of my equation. So now I've got 2y, 4y minus 2y is 2y, set that equal to 7. And then my next step would be to add 3 to both sides. And now I've got 2y equals 10. I'm going to come back up over here and keep it going. So I've got 2y equals 10. To solve for y, I'm going to divide each side by 2. So I would get y equals 5. So we used our algebra skills to solve. And y would equal 5. And we are all done. Notice here it did just say solve for y, but a lot of times a problem might say find the length of a side. So make sure that you're answering each question completely by making sure that you go back and reread what the question asked and make sure you answered the question fully. That's a mistake I'm seeing some of you are losing easy points on by maybe not completing the entire question all the way. So when you're done with the problem, always go back and reread the question, make sure you answered it entirely. I'm going to go on to the next slide, so if you need more time here, go ahead and click pause so that you can continue taking this down your math notebook. Reminders, there is about only 6 weeks left in the semester. So be sure, now that you're aware of this, that we are getting close to the end of the semester, be sure you're working on submitting any missing work if you have any. We are now working in Unit 3, so there is no more redos from Unit 2. Because we are now working in Unit 3, there's no more redos from Unit 2. Remember, we can only redo assignments from that current unit we're working on. All right, I kind of already talked about this. Just to make sure that everybody is answering the question asked, make sure that you're answering all parts of the question. So sometimes if you're asked to find a length of a certain segment of a figure, sometimes you might have to first solve for a variable and then replug it back in. So just make sure that you're answering all parts of the questions. All right, so let's go back to what we were learning about last week with parallelograms. Let's review all the properties of parallelograms because this week we're going to learn about special types of parallelograms. So we want to make sure that we really understand the properties of parallelograms to take that a step further and look at the special parallelograms that we're going to learn about this week, rectangles, squares. So parallelograms are always quadrilaterals. They're always going to have 4 sides. The opposite sides in parallelograms will always be congruent. The opposite angles will always be congruent. The opposite sides will always be congruent in parallelograms. When we have our diagonals, and that's when we draw from one vertex straight across to the other vertex, that's a diagonal. The diagonals will always bisect each other. And remember, bisect, that means it's going to divide them into 2 equal parts. And then the adjacent angles, sometimes we call those consecutive angles, will always be supplementary. So if we add those 2 angle measurements together, we should always get add up to 180 degrees. So those are our properties of parallelograms. So let's use some of these properties to solve some problems. So here is a parallelogram. So this figure is a parallelogram. I'm going to tell you that right now. And knowing that that's a parallelogram, I want you to use all the properties of parallelograms to help you find the values of x and y. So here's x, here's y. And then you're also going to find the measurement of angle ABC. So we're going to find this angle right here, angle ABC, as well as angle DAB, so this angle up here. All right, so first of all, can we find the value of x? So that's the first task, is that we need to find the value of x. What would be the value of x? So what do we know about parallelograms? What property would help us solve this? X is representing the length from D to E, so it's a segment of our diagonal, and we know that the diagonals bisect each other. So we know, based on that fact alone, that the measurement of DE has to be congruent to the measure of EB, because the diagonals bisect each other. Well, look, we know the length of EB is 15, so that means that the length of DE must also be 15. So x would have to equal 15. So first one done, we found x. We found the value of x. Now we need to find the value of y. That's our next task. Find y. So y is the length it's involved with the length of A to B. So what do we know about the opposite sides of parallelograms? Well, right here, we know that the opposite sides of parallelograms are congruent. So AB, that side, has to be the same length of the side opposite. So AB is going to be congruent to that side opposite of it, which is DC. Well, we know the length of DC is 22, so that means that AB must also be 22. So now we know that AB is equal to 2y, right? And we know the length of AB, the entire length is 22. So if the entire length is 22, and we know that AB is represented by 2y, we just need to solve for y by dividing each side by 2. And we get y equals 22 divided by 2 is 11. So y would equal 11. So we've solved for y. Here's our x over here. And then I'm going to erase this, so I want you guys to make sure you have this in your math notebook now. So I am going to erase everything because we need to go on and find those angle measurements. So I'm going to erase everything so far so that I have room to do the next set of calculations. So go ahead and click pause now if you need to copy down these notes in your math notebook so that you can solve problems just like this when you see it on your homework this week. I'm erasing everything. All right, so now let's go back. So we want to find ABC. So ABC is this angle measurement right here. What can help us find that measurement of ABC, that angle measurement? Do we know the angle measurement of BCD? So this angle measurement here is really the only other piece of information that we're given. So the measurement of angle BCD is equal to what? 18 plus 31, which is 49? Yeah? And what do we know about our properties of parallelograms that can help us? Consecutive angles are supplementary. So we know that the measure of angle BCD plus the measurement of angle ABC has to add up to equal 180 degrees. Well, we know that the measurement of BCD is 49, and we don't know the angle measurement of ABC, but now we have enough information to help us solve it. So we're just going to subtract 49 from 180. And what do you get? 180 minus 49 is 131. So the measurement of angle ABC would be equal to 131 degrees. And we were able to do that by using that property that we learned there where consecutive angles are supplementary and what we were given. Now we need to find the measurement of DAB. So the last thing that we need to do is find the measurement of angle DAB. So DAB is this angle right here. Well, what can we use to help us solve this? Opposite angles are congruent in parallelograms. So the angle opposite, we know that the angle measurement is 49, don't we? We know that that measurement opposite is 49. So we know that the measurement of angle DAB would have to be equal to 49 degrees as well. And we're all done. So that was a great problem. It really hit on all the properties of parallelograms that we can use to help us find unknowns in different parts of parallelograms. I'm going to go to the next slide now, so if you need more time, go ahead and click pause so that you can finish up with your notes. Let's see here. Let's look at another question. So the question says, is the quadrilateral a parallelogram? What are we given? We are given some vertices of a parallelogram, but we don't even know. I guess it should say, this should say of a quadrilateral, because we don't know yet if it's a parallelogram. We know it's a four-sided figure. So we're given 4 points, and we know any 4 points when we connect them would make a quadrilateral, but we want to know specifically if this quadrilateral is a parallelogram. So let's go ahead and plot the points. So A is at -3, 2. So I just want to have a visual of what we're dealing with here. 2 and 2 is B. C is at -5, -1. And D is at -3, 1. So, is that right? Did I do that? -3 up 2, that's A. B is at 2, 2. C is at -5, -1. And D is at -3, 1. So that really doesn't even look like a parallelogram when we plot them. So right away we could probably tell we're not dealing with a parallelogram. Something just looks weird. Okay, so there is a mistake there. I changed the coordinate of point D. I wanted to change that coordinate of point D because that was not right. That was not looking like what it was supposed to be when I plotted it. So I changed the coordinate of point D to be 0, -1. So looking at these vertices is, if we were to combine or to draw in, connect these, would it be a parallelogram? And how would we be able to prove for sure it was? So let's focus on the fact that opposite sides are parallel. So we could find the slope of the opposite sides to determine if they were parallel. So to go from, let's say, point A to C, how would we get from point A to C? So it looks like we went up 1, 2, 3. So our slope would be 3. And then we went to the right 1, 2. up 3 to the right 2, rise over run. Now the side opposite to it should have the same slope because remember opposite sides are parallel, which means opposite sides will have the same slope because we know parallel lines have the same slope. So now let's look at the opposite side from D to B. So we would go up 1, 2, 3 and to the right 2. So we have the same slope of 3/2. So that's good. Now what about the other two sides? From A to B, we can just count. We would go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. They have the same length. So we know the opposite sides are congruent. So we know this is a parallelogram because the opposite sides have the same slope and we know the opposite sides are congruent. So again, we're using more of the properties that we learned about parallelograms to help us solve problems and to really back up our answers. Not just draw the shape and say, well, it looks like a parallelogram. I want you to take a step further and use what you learned to defend your answer, to really back up your answer. Going on to the next slide. So, parallelograms are quadrilaterals. Parallelograms are quadrilaterals because quadrilaterals are any four-sided figures. Now we've been focusing on parallelograms the past, just last week. This week we're going to look at special types of parallelograms, which include rhombuses, rectangles, and squares. So a rectangle is a type of parallelogram. It's a special type. A rhombus is a special type of a parallelogram. And a square is also a special type of a parallelogram. So rhombuses, rectangles, and squares are going to share all the properties of parallelograms. And then they're going to have some properties that are specific to that special shape. So for example, a rhombus, or let's look at a square, for example. A square we know is, because we're all familiar with this shape, so that's why we're going to look at this. A square, remember parallelograms have to have opposite sides that are congruent. That's true in a square. Opposite angles are going to be congruent. That's true in a square. Opposite sides are parallel. That is true. Consecutive angles are going to be supplementary. Well, all angles in a square are 90 degrees. So that is true as well. Now what makes a square special is that all sides are going to be congruent. Not only are the opposite sides congruent, but all sides are congruent. And then all angles are 90 degrees. But as I noted before, it's still, all the properties it has are the same as a parallelogram. So a square is actually a parallelogram. It's a special type of parallelogram. And the same is true for a rectangle. A rectangle is going to be a special type of parallelogram. Here the opposite sides are congruent. The only thing that's different and special about a rectangle is that all angles will be 90 degrees. So this is a cool chart because you're going to be asked questions this week of like sometimes, always, and never. So like I could ask you, is a square a parallelogram? And you would say yes, always. A square is always a parallelogram because it has all the properties of a parallelogram. We could say a rectangle is always a type of a parallelogram as well because a rectangle is always going to have all the properties of parallelogram. We could now say that, what about this question? Is a rectangle a square? Well, a rectangle, or is a square a rectangle? That is always true as well. Is a rectangle, so it's kind of like when we did that question with the isosceles, is an equilateral triangle always an isosceles, and is isosceles always a equilateral? So it's kind of the same as that. So what are the special parallelograms again? Rectangles, rhombuses, and squares. And here let's see what their properties are. So a square, let's talk about a square because I think we're most familiar with that. is, oh, actually, let's talk about a rhombus because it's kind of got this hierarchy here. So here's our properties of parallelograms. We're familiar with that. All sides are congruent, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. So we've got opposite sides that are parallel. Rhombuses. So a rhombus is going to have all four properties of a parallelogram, but in addition to that, the diagonals are going to be perpendicular to each other. So this is a little bit different. All the diagonals are going to meet at 90-degree angles. And then the diagonals bisect the opposite angles. So they're going to bisect into equal parts here, the angles. So that is a little bit different than a parallelogram. We added those two additional properties to make it a rhombus. Now, a rectangle, something we're also familiar with, has all the properties of a parallelogram, but in addition, the diagonals are going to be congruent. So that's a little bit different. The diagonals are congruent. So now squares have all the properties of everything above it. It's got all the properties of rhombuses, all the properties of rectangles, and then, so that's what makes it a square. So a square is going to have all the properties of parallelogram, all the properties of rectangles, and all the properties of rhombuses. So a square will always be considered a rhombus and always considered a parallelogram. Always. A rhombus can sometimes be considered a square, depending on if it meets all the properties. So keep that in mind when you're working through this week's assignments on the properties when you are dealing with rectangles, rhombuses, and squares. So squares has every property above it of rectangles, rhombuses, and parallelograms. So let's practice here. So here we've got a rectangle, and we know the properties of rectangles is that the diagonals are congruent. So let's write that up here. Diagonals are congruent in rectangles. That's what separates it from being a parallelogram. So it's got all the properties of parallelograms and the diagonals are congruent. So we've got some measurements, some side lengths measured, and then we're told from N to L, so the entire length of this diagonal is 26. And we want to find the length of MO as well as NZ. So MO is from M to O. So remember, we learned that the diagonals are congruent in rectangles. So if we know now that the diagonals are congruent, we now know that the length of MO has to be congruent to the other diagonal NL. Well, we know that NL is 26, so we also know that MO must also be 26. So the length of MO has to be equal to 26 because the diagonals are congruent in rectangles. What about if we wanted to find the length of MZ? So MZ is from here to here. So what is a property that we learned about parallelograms and their diagonals? Because remember, a rectangle is a type of parallelogram, so this property is going to hold true to it as well. Well, we learned that the diagonals will bisect one another. So bisect means to divide into two equal parts. So we know that the length has to be half of 26. So MZ has to be equal to half of 26, which is 13. So to solve this problem, we used some properties of parallelograms, which also apply to rectangles. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. And that brings us to a key phrase assignment. Let me put that up. So this week, I want you to tell me everything that you learned about the diagonals of rectangles. So I want you to list everything that is true about the diagonals of rectangles. And remember, that might include the diagonals of parallelograms because a rectangle is a type of parallelogram. So that's your hint. Have a great rest of your week.